If your child is entering the 4th grade or above and they do not yet know all 156 of these multiplication facts fluently, that is, they can recall these facts quickly, don't worry, this video is for you. As a teacher, I can tell you success in 4th through 8th grade math heavily depends on your child's knowledge of their math facts. But most people teach their children with flashcards or repetitive worksheets, and it can feel like pulling teeth getting children to memorize this. Here's what you're going to do instead. And just before we get started, your child should know the concept of multiplication before you teach them these facts. So if you have a 1st or 2nd grader or even 3rd grader who doesn't yet understand the concept of multiplication, teach them that first. So we're going to start with the zero property, and that is, in multiplication, anything times 0 is 0. That's pretty easy. Why? Because 0 groups of 2 is 0. We have nothing. Next, we're going to teach the most important property, which is the commutative property of multiplication. The commutative property says that we can multiply numbers in any order, and that does not change the answer or the product. That means that if you know that 0 times 1 is 0, 1 times 0 is also 0. And if you know that 0 times 2 is 0, then 2 times 0 is also 0. So now we can fill in this row. We want to really take our time here with the commutative property, because once a child understands it, it's going to cut down the number of problems they have to memorize in half. When I tell my 3rd graders that I expect them to learn all of these problems within a couple weeks, they go, "Miss Mays, that's so many problems. How are we ever going to learn them?" But I say, wait, hold on. You didn't learn about the commutative property yet. So if you know that 3 times 7 is 21, you also know that 7 times 3 is 21. And that means if you know that 2 times 5 is 10, 5 times 2 is also 10. So there's not that many problems you actually have to know. So once my students understand that, in the first couple of weeks, you'll see them filling out those little timed worksheets, jumping all around because they notice the commutative property on their worksheet. So to teach this, I tell students that having 2 groups of 3 objects gives us the same number of objects as having 3 groups of 2. Or 2 rows with 6 eggs in each row gives us 12, and 6 rows with 2 eggs in each row gives us 12. You're going to have to review this property every day for children to really internalize it. Next, we teach the identity property. The identity property of multiplication says that any number times 1 is that same number. Now, I don't use that terminology with students because it confuses about a quarter of them. Instead, I say this. If I have one group of 9 M&Ms in this hand, how many M&Ms do I have? 9. If I have one group of 6 M&Ms, how many M&Ms do I have? 6. If I have one group of 1,000,000 M&Ms in this hand, how many M&Ms do I have? 1,000,000. And so that makes this pretty easy to figure out. Don't underestimate the child's ability to get that identity property confused with addition. So really take your time and give them that visual representation and use those words, one group of blank. Again, with the commutative property, once I know these ones, I also know these ones. So we can fill it out just like this. And I do like having a huge chart like this so kids can physically see what we're doing here. There we have it. I am interjecting here to let you all know that I am teaching 3rd and 4th grade math this year, the whole curriculum. Why 3rd and 4th grade? Because that's what my kids are in, and it worked really well this past year having other people join my kids in the course. It helped me accountable and also helped you guys out a lot. So you can sign up for that at akibamaze.com/courses. Now we're going to fill out 3 columns that children generally know based on their prior knowledge. We just need to activate that prior knowledge. So the first is the 2s. Most kids know how to skip count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Besides skip counting, I also remind them that the 2s are just double that number. So what's double 3? 6. What's double 5? 10. Most kids are really good with their double addition, and so it's really easy for them to do the 2 times table. The next column that most kids will know is counting by 5s. And so we do the 5 times table. If your child does not know the 5 times table, I highly recommend them watching this video, the Schoolhouse Rock 5. I just put that video on every single morning until my kids get sick of it and they know their 5s back and forth. So generally takes about a week. I have the video playing. Here we go. Ready, go. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. And they go all the way up to like 100 and something. And then the third column that most children know how to do is the 10s. So most kids can count by 10s. We go to the 10s and we go 10, 20. I do it that way, and I definitely do teach the child, hey, look at the pattern. When we wrote out the 10s, a faster way to write the 10s is to write the number we're multiplying 10 by and add a 0 at the end. If your child doesn't quite have counting by 10s down, that is going to be your evening assignment. You all are going to be counting by dimes or counting by $10 bills if you have it like that. And again, remember, if you know the 5s, if you know the 10s, if you know the 2s, then you can fill out the rest with the commutative property. So now we fill out all the 2s going this way. And we're filling out all the 5s going this way. And all the 10s going this way. So at this point, you're about a week in and your child has mastered 70 problems already, like this. And I tell kids that. I say, look, we're only a week in, you've mastered 70 problems. Next, we're going to look at patterns in 2 of these columns, and we're going to learn a song for 1. So starting with our song, that Monday morning, I start by putting on the 3s song. 3 is a magic number by Multiplication Rock. So I start the mornings off with that. So the whole week they're learning their 3s. And since it's a nice magical song, if you play it every morning and then every night, they internalize it very quickly. 3, 6, 9.
3, 6, 9, 12, 15, 18, 21, 24, 27, 30.
We'll talk about those last 2 in a minute. Okay, let's talk about the patterns in the 9s and the 11s. We'll start with the 11s. So I have children figure out the answer to the multiplication facts first. And so then we'll have them down. And I ask them, hey, what pattern do you see in the 11s? Well, obviously up until 11 times 9, excluding 11 times 0, we just have the number repeated. And again, don't underestimate or overestimate your child's memorization. And I like to say it like this so that I make sure they remember the 11. 11 times 1 is 1, 1. 11 times 2, 2, 2. 11 times 3, 3, 3. 11 times 4, 4, 4. 11 times 5, 5, 5. 11 times 6, 6, 6. 11 times 7, 7, 7. 11 times 8, 8, 8, and so on. The reason I don't say 11 times 5 is 55 because it just seems to make kids have to think more, and I want them to almost stop thinking for a second and make it just be automatic. Once we know our 11s this way, we know our 11s this way. The 9s trick. I do the same thing with the 9s. I have the child figure out the 9s and then we look at the patterns. Now you notice I did not do 11 times 11 or 12 times 11. It doesn't fit that 11's rule yet, so I'm just gonna wait. We'll get to those. Now that we have our 9s written on the board, I asked children to tell me what patterns they see, and I would let them figure it out, but I'm just going to tell you. With the exception of 9 times 0, we notice something. When we look at the 9s this way, we notice that the 10's place is increasing by 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, up until there. We notice that the 1's place is decreasing by 1. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. What else do we notice? Well, I notice if I add the digits of the answers, the sum or the answer is 9. 0 plus 9 is 9. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9, 4 plus 5 is 9, all the way down here. So what does that help us do? We can take a look at this number here, and we're going to write the number that comes before this number. So we'll write 1 here. 1 comes before 2. And then what do I need to add to 1 to get to 9? Because remember, the sum has to be 9. I have to add 8. And here's how I do it so that it becomes just a repetitive thing in the child's head. The number before 3 is 2. Add 7 to get to 9. The number before 4 is 3. Add 6 to get to 9. The number before 5 is 4. Add 5 to get to 9. The number before 6 is 5. Add 4 to get to 9. If your child isn't that strong in addition, I would physically show myself counting up to get to 9. So it would look like this. The number before 7 is 6. 7, 8, 9. I write a 3. The number before 8 is 7. 8, 9. I write a 2. The number before 9 is 8. 9. This is 90, and we know we have this 11s, 99. And so, now that we know our 9s, because of the commutative property, we can fill out the 9s this way. We don't know 9 times 12 yet. And now, we started off with needing to know 156 problems. Now we're taking it down to about 30 that we have left to memorize. And we haven't even done any memorization yet. But actually 12 of those we're going to solve using the commutative property. So there's just 18 problems we have to memorize. We're going to knock out 6 of those easy ones right now, and that's going to be their doubles facts. For whatever reason, doubles facts seem to be really easy for kids to memorize. Maybe it's just seeing those doubles like 6 and 6 and they just know automatically. So we'll take a few days and we'll go over the doubles. And when I say a few, I mean like 2 days to really memorize these few doubles facts. Ooh, I can barely see what's left up here. So that would be their 4s double, 16. Their 6 doubles, 36. 7 double is 49. Their 8 doubles, 64. And their 11s double, 121. And their 12s double, 144. This is where flashcards come in handy, helping to memorize those doubles facts and going back over the facts that they now know and reviewing that commutative property. So I'd put my flashcards in a specific order. I'd have 4 times 5, and the next card should be 5 times 4, because the goal is for them to remember these automatically, and then we'll switch it up. So now we're just down to 12 problems that your child needs to memorize, and I'm going to give you some quick tips on how to remember those 12s. The 4s are just double the 2s. 4 times 3 is just double 2 times 3. So if you know that 2 times 3 is 6, we double that for 4 times 3. Double the answer and we get 12. So 4 times 6 is just double 2 times 6. So if 2 times 6 is 12, 4 times 6 is 24. And if 2 times 8 is 16, then 4 times 8 is 32. And if your child is really good at addition, which they should be, if they're not good at addition, you shouldn't be going on to multiplication, then they will know how to add 16 plus 16 in their head. We did 4 times 6, so what can we do? 6 times 4. And we did 4 times 8, so what can we do? 8 times 4. Same here. 4 times 7 is double 2 times 7. 2 times 7 is 14. So 4 times 7 should be 28. So 7 times 4, 28. Oh, I forgot. We did our 3s, and so we could fill in our 3s this way. Our 11s should be filled in. And what about the 6s? The 6s are just double the 3s. So if we want to know what 6 times 7 is, we can think about what 3 times 7 is. 3 times 7 is 21. So if we double that, 6 times 7 is 42, which means 7 times 6 is also 42 because of the commutative property. And if we want to know what 6 times 8 is, we just look at what 3 times 8 is. 3 times 8 is 24. We double that to get 48. And we know 6 times 8 is 48, so 8 times 6 is 48. There's only 2 things left to do now. The first thing is to memorize the 12s. I think the 12s are just a fun challenge to get kids to memorize. And again, just like the doubles, I think because they see a 12 and it's just a bit more memorable to have them learn the 12. So it's a little bit easier. And then also there's the fact that if you write it out like this, as you increase by 1, so 12 times 5, if we increase what we're multiplying by, so 12 times 6, we're just adding 12. Remember, multiplication is repeated addition. So each time we're going this way, we're adding 12, adding 12, adding 12. So that's one way kids can fill this paper out. Just use flashcards here and have them learn their 12s. It's not much that we're memorizing here. Okay, and then again, once you know the 12s that way, commutative property, we can fill out the rest of these. And then the final thing, oh, my head is in the way here, but is learning 8 times 7. And then by default, 7 times 8. And what I do with this last problem, I just say, and of course, 8 times 7 is 56. And I leave that as like the last problem of the day. So by the time you get to the end of week 2 or 3, they're like, of course, 8 times 7 is 56. That's it. If you thought this video was helpful in any way, please give it a thumbs up and also share with somebody else. And maybe put a smiley emoji. I don't know. Do something.